Hi everyone, I hope you're doing well. In this video, I'm going to solve this truss problem here, which requires us to implement both method of section as well as method of join. So the question here says that determine the forces or their vertical and horizontal components for the truss shown in the figure of members A, B and CD by using a single moment equation. Now this is my interpretation here that the examiner is asking you to use method of section to determine member forces in member AB and member CD. So cut a section in such a way that it passes through member CD as well as member AB, and we will use this sectioned truss and apply conditions of equilibrium to determine the value of member forces AB and CD. And furthermore, it says that we have to solve for joint E, and here we need to apply method of join to determine the member forces in member AE and member DE. To start off the question, we will evaluate or calculate support reactions or external reactions. There will be two reactions at this pin support. Let's name this vertical reaction as RAY and this horizontal reaction as RAX. And at rotor support, we only have one vertical reaction, and let's name it as REY. So first, applying condition of equilibrium, summation of f of y equals to 0, taking upward force as positive. If this is x and this is y, we can see here that we have two forces that are acting in y direction, RAY and REY. And RAY is going to be positive since it's going upward, matching my sign convention, as well as REY. And from here, RAY is equal to minus REY. Now applying second condition of equilibrium, that is summation of f of x equals to 0, and taking rightward force as positive. And we have RAX acting in right direction. RAX is going to be positive, plus 40 and plus 20. And do we have any other force? No. So this is going to be equal to 0. RAX from here is equal to minus 60 kilonewton. Minus 60 kip, sorry. And the minus sign here indicates that the direction of this reaction is incorrect, and this should be acting towards the left to maintain equilibrium in this truss. And this is equal to 60 kips. Now applying third condition of equilibrium, that is summation of moment. Let's take moment about a point equals to 0. Take clockwise moment as positive. And we can see here we have this RAY reaction creating counterclockwise movement, 40 kip force creating clockwise movement, this 20 kip also creating clockwise movement. So this REY is going to be negative since it creates counterclockwise movement about this point, and it has a perpendicular arm, that is the perpendicular distance of this force with respect to this point is equal to 12 into 4, which gives us 48 fit. 48. And we have this 40 kip force creating clockwise moment and has a perpendicular arm of 20 fit. Similarly, this force is also creating clockwise moment. 20 into 40 is the perpendicular arm for this force. And if you solve this, RUI is equal to 33.33 kip. And if you substitute this value of REY here, RAY is equal to minus 33.33. Again, the minus sign here indicates that the direction of this reaction was assumed incorrect. It should be pointing downward. That is downward 33.33 kip. And here it's equal to 33.33 kip as well. Okay, now we'll cut a single section through member CD and member BA so that we can try to determine member forces within them. And the section would be something like this. And we will apply conditions of equilibrium to this sectioned truss to determine member forces within member AB and member CD. After cutting the section, we will show the internal force within the member with arrows. So this force would be FBA, FCD, and FBD. And before applying conditions of equilibrium, let's resolve FBA and FCD into their components. And if I take theta here, this component adjacent to theta would involve the term of cos theta, FBA cos theta, and this term, and this component, the other component would be FBA sin theta. And for this force, I'm going to take theta here. Let's name this as theta 1, which means that this component would be FCD cos theta, and this one would be FCD sin theta. Now we will calculate the value of theta and theta 1 by using truss geometry, and this theta is an angle somewhere here, and we can see that this theta is equal to the angle at point B, and we can use this right angle triangle to determine the value of this theta. So in this case, this becomes perpendicular, and this is the base of this right angle triangle, and tan theta is equal to P upon B, perpendicular upon base. Perpendicular in this case is 12 feet and base is 20 feet, and if I calculate theta from here, it would be equal to tan inverse 12 over 20, which gives me 30.96. And to calculate this theta 1, we can see that this is an angle somewhere here, and from truss geometry these two angles are equal. And to calculate this angle, we will use this triangle, this right angle triangle. So this is the perpendicular for this right angle triangle, and this is the base. And if you apply the same trigonometric function, tan theta is equal to perpendicular upon base, and perpendicular is equal to 20, base is equal to 12, theta from here is equal to 59.036. Okay, now we can apply conditions of equilibrium. So the first condition that I'm going to apply is summing the moment about D point, about this point here. And we can see that these two forces, FBD and FCD, won't create any moment about this point because their line of action, or these forces, are passing through these points. And there are only two forces which are creating moment, this FBA and this 20 kip point load. And furthermore, I'm unable to compute the perpendicular arm of these components with respect to D point. And we will use the concept of principle of transmissibility and slide this vector force FBA and its component to this point. So we can see that FBA sin theta is also not creating any moment about point D, as its line of action of force is passing through D point. So we have FBA cos theta creating moment, and it has a perpendicular arm of 24 feet. And theta is equal to 30.963. FBA from here, from this equation, is equal to 19.4363 kips. And now we will apply second condition of equilibrium, that is summation of f of y equals to 0. And we have two forces acting in vertical direction, FBA cos theta and FCD sin theta. FPA cos theta, and theta is equal to 30.963, and another force is, and this should be negative since it's going downward and my sign convention is upward, and this force is also going downward, hence negative FCD sine theta 1. Theta 1 is equal to 59.036, equal to 0. Substitute the value of this FPA here. And from here FCD is equal to minus 19.4365 kips. And the minus sign here indicates that this force is in compression. And this force here, since it's positive, this is in tension. And now we are going to solve for joint E. That is, we are going to isolate this joint and apply conditions of equilibrium and determine unknown forces at this joint. Let's do that. So at joint E we have FEA and FED, and we also have a support reaction 33.33 acting here, 33.33, and we have to resolve this force into its component. And if I take this theta here, and this theta would be equal to theta 1. This component would be FED sine theta, and this one FED cos theta. So first condition that I'm going to apply is summation of f of y equals to 0, taking upward force is positive. We have FED sine theta, and theta 1 was equal to 59.036. FED from here is equal to minus 38.869, and the negative sign here indicates that this force, internal force, would be in compression. Now applying summation of f of x, summing the force in x direction and taking leftward force as positive. We have FEA and FED cos theta acting towards left, hence both will be positive. FEA is equal to 19.99, which is approximately equal to 20 kip. And we are done with this question. Thanks for watching till the end, and take care.